All right, this is chapter 8. It is on special senses. We have 4 special senses. We're going to go through 2 in this recording. These are just some cool optical illusion videos that I will post on Google Classroom for you to check out. So our 4 special senses, and on your notes, you guys will see the blanks that you guys will fill in the information on. So if you have to, you can pause the video if you need more time to write it. Feel free to do that. So our first one is smell. This is in what's called olfactory organs. And then we have taste. This is in our taste buds. And then our hearing and equilibrium is in our ears. And then sight is in our eyes. So the first one we're going to break down is smell. So you have what's called olfactory receptors. These respond to like chemicals and stuff like that in different liquids. Olfactory organs, they contain the olfactory receptors and support what's called epithelial cells. We went through the different types of cell tissues, and that's what this type is epithelial. And they're found in the superior portion of the nasal cavity. And then once those receptors are stimulated or woken up, the nerve impulses travel. They travel through the nerves to the bulbs, to the tracts, and then to our limbic system. And that kind of tells us like, hey, this smell does not smell very well, or maybe it smells good, or whatever the case. So our emotion to it. And then our olfactory cortex interprets that. Here is a like visual of those terms. So you'll have the olfactory bulb. So this picture is just this little bitty portion blown up. So this is our olfactory bulb, kind of the thicker part there. And then the tract kind of comes down here. The mucus inside your nose is shown right here. And the mucus layer, just the little hairs or cilia. The receptor cell would be here. And these are supporting cells and everything. And these are like the filaments of the nerve. So it kind of helps to see a visual of that. Okay, taste is next. So you have taste buds. They're located on the papillae. These are the ridges of your tongue, the roof of your mouth, linings of cheeks, and walls of your pharynx. Your taste receptors, so you have taste cells and you have taste hairs. I don't think you have to fill anything out on this little part, but it's modified epithelial cells that act as receptors, and then your hairs are little microvilli that protrude from your taste cells. These are like the sensitive parts to the receptors. Okay, and then the 4 primary taste sensations, this would be sweet. These are stimulated by carbs. Sour, stimulated by acids and sour compounds. Salty would be stimulated by salts. Bitter is stimulated by many organic compounds. And then spicy foods, they activate our pain receptors. Some of you have more weak receptors on this end than others, possibly, if you can handle a lot spicier food than others. And then on the spicy foods was on the next page. And then on D, our sensory impulses, they travel along our cranial nerves to what's called the medulla oblongata, to the thalamus, to what's called the gustatory cortex. So our taste is interpreted in the brain in this. And here is a visual or picture of our tongue and the papillae. Our tonsils, some of you had to get those removed, possibly the epiglottis, just as a visual here. And then a video I want you guys to watch, and I'll just play it on this recording. Why does spicy food burn your mouth? See if I can get it on here.
That look. That look is a look that can only happen by a roaring fire at a Verbo cabin.
Wait for the ad.
Possible, but you humans are pretty weird. I mean, a good amount of you like spicy foods. You like the food that gives you the sensation of heat and pain. Why? It might be something I will never understand, but I can tell you why you get those sensations in the first place. Let's start off by taking a look at our tongue. It's covered in a bunch of tiny bumps called papillae, or papillae, that contain our taste buds. This is where the chemicals from our food are detected, sending a signal up to the brain. This is later combined with sensory information about the food's odor, texture, and temperature that give our food its unique flavor. In addition, we also have heat and pain detecting VR1 receptors in our mouths. These are the things that tell us maybe drinking this scalding hot cup of coffee isn't the best idea. Normally, they will only respond to temperatures greater than about 42 degrees Celsius, but they can also be tricked. In spicy foods like chili peppers, an ingredient called capsaicin binds to these receptors, which sends a signal to your brain that something is hot in your mouth. This then gives you a burning sensation and triggers the physical reactions of heat, making you sweat and turn red. Of course, there's not actually anything hot enough to do damage to your mouth, but our brain mistakenly thinks that there is. Something really cool is that not only does capsaicin cause a painful burning sensation, but it can also be a pain reliever. See, after the initial exposure, the receptors will be desensitized and won't respond as strongly to the stimulus. Knowing this, scientists now have different creams that contain capsaicin and are being used to treat arthritis pain. So what some people eat to feel a burn, other people use to alleviate their own pain. Kinda strange how nature allows for both, huh? Do you like spicy foods? And if so, what is the spiciest food you've ever eaten? Or you can tell us what we should talk about next. Domain.com is the place to go when the next great idea hits you.
Okay, so that was just a little video, like why does spicy food burn your mouth? Maybe you never even thought of that, but that just explains it and goes into that further. Helping to heal a burnt tongue if you ever do heal or ever do burn your tongue. Sugar is supposed to help if you ever have to do that. And then this next picture is our ear diagram, and I'll post this on Google Classroom so you can pull it up whenever you need to help you fill out your chart. And I'll probably do a different recording on the ears, so I will end this one here.